All right, we're live. Hey, everybody. Welcome to Across the Tenancy Spectrum. Super exciting to do this initial stream here with my co-founder and CTO, Fabian. Fabian, why don't you introduce yourself?
Sure, yeah. I'm Fabian. I'm co-founder and CTO here at vCluster Labs. And I'm responsible for a lot of kind of the technology that we have and at least participated there. And really excited to be here today and talk a little bit about kind of our last recent advancements and vNode in particular.
Awesome. Yeah, we named the show Across the Tenancy Spectrum. And that's because, when, the two of us started vCluster, we've obviously started it to solve multi-tenancy in Kubernetes. We were struggling ourselves in, the previous company and product that we're trying to build with multi-tenancy in Kubernetes. So we saw this problem firsthand, solved it with an open source project, and then obviously got in touch with so many people in the space and saw so many approaches to solve multi-tenancy. And we realized, it's really not single tenancy versus multi-tenancy. It isn't a binary decision. Tenancy is rather a spectrum of possibilities. Sometimes you need the network completely hard isolated. Sometimes it's okay to just have, network policies. And, other times, the overlay, the underlay, right? Like certain things need to be isolated. Sometimes the storage can be shared, other times it can't. You potentially want to run on the same nodes. Sometimes you need different node groups. Sometimes you want an entirely separate control plane. There are so many degrees of, decisions you have to make in order to say, is this more soft multi-tenant or more hard multi-tenant, or is it, complete single tenancy? That's why I essentially named the show like this. And we're trying to do this live stream every couple of weeks, hopefully, exploring one technology that helps across this tenancy spectrum in order to isolate certain things or make certain things easier, automate a couple of things. And today we're going to look at vNode. vNode is a very, very new product we started earlier this year. We announced it at KubeCon Europe in London. And Fabian, why don't you tell us a little bit about the inspiration and how do we get started with vNode?
Yeah, so I mean, vNode, maybe, I'm not sure if anyone is really familiar with it right now, but it's based off the idea that there's a lot of kind of like container runtimes already out there, right? So obviously there's kind of like these standard ones. So there's containerd, CRI-O, these more like regular container runtimes, right? And then there's these more security-focused runtimes, such as like gvisor or Kata container. Also Sysbox is out there, which is great. However, kind of like all of them didn't match like our use case where we wanted a non-VM runtime, right? So like a regular container runtime that essentially allowed us to run still privileged containers. So for example, like Docker and Docker, or even Kind, K3s, like these more like things that require privileges. And none of these was really able to do this in a way where we said like, hey, this is kind of like compatible with Kubernetes as well, right? So some of them worked well with Docker, some of them kind of like worked well in different settings. Some of them had like VMs, but none kind of fulfilled all these requests and requirements that we had. So we thought like, hey, we see an opportunity here. We think there's like a gap, right, for like bare metal security container runtime. And that's essentially kind of like the start of vNode.
Awesome. Yeah. Let's maybe start there. I think there's a lot of confusion around, vNode, Kubeflow, gvisor, Kata containers, right? There are so many options. And maybe let's start with a pretty trivial question. Containers versus VMs. Where's even the difference? And maybe you wanna start with answering that question for us.
Yeah, that's a good question, and that's actually like that can go from like a very easy explanation to like a very detailed and complex technical explanation, right? So the easy explanation is kind of that you in a VM you essentially have like a thing called hypervisor, right? And there's different types of hypervisors. So there's hypervisor type 1, which is like KVM, Hyper-V. Then there's things like hypervisor 2, which is essentially things like VirtualBox, for example, which operate on the operating system level, right? While hypervisor type 1 basically operates more like on the bare metal level, so there's no OS in between. And essentially the way this hypervisor works is it provides a kind of like isolated piece of a machine to a subsystem. And that's usually something like another operating system, right? So like virtual machines can really be used to run separate operating systems, right? So you could run something like Windows in a Linux machine, or you can run another Linux system in a Linux. So there is really kind of like always a separate kernel involved. So that's kind of like really the distinction to containers, where you share a single kernel, right? And in almost like every container technology, right, you always have this single kernel that essentially isolates containers with Linux namespaces and C groups and seccomp filters. So it's kind of like a different combination of technologies there that essentially make up a so-called container, right? And not every container is the same as well. So there's like always kind of like different nuances to it. But yeah, the underlying kind of like main difference is really for VMs, you have a hypervisor and separate complete operating system, right? While for containers, you share a single kernel and do the isolation through kernel features, essentially.
So let's dive a little bit deeper into this. But before we do, just a reminder for everybody, this is supposed to be very interactive. Feel free to ask any questions. I'm going to ask a bunch of questions here. I'm trying to learn from my CTO. I consider myself fairly technical, but you can go probably like much deeper than I can. So I see this as a little bit of a learning exercise for myself as well. Anybody who's streaming here, feel free to leave any comments, ask any questions. We're trying to pull them in and see if we can answer them all along the stream. Just to give you a little bit of heads up, we're going to talk obviously a little bit about vNode in this session, and what technologies it's built on top of. We are going to see a little bit of a demo as well. I think, Fabian, you prepared a couple of small things for us here. And I've seen you run a couple of really impressive demos with container breakouts and then explain how it works. And essentially see, the same thing with vNode and explain the differences. So I'm really excited about that. We're also going to talk a bit about, how this interacts with vCluster, for example, and, how this compares to other runtimes. But somewhere in the middle, I don't know where it fits in best. We'll see. We'll probably also talk about NVIDIA Escape, which was a container escape, a breakout that Wiz discovered in July, and our team dug pretty deep into this vulnerability. I think it's a really exciting one. It actually happens before the container even got created, and we should definitely dive into the creation process of container to understand how that generally works. But then also take a look at what happened during NVIDIA Escape and why is that such a interesting vulnerability. Just to give everybody a heads up of what we're trying to cover today. But let's go back to what you were just explaining: containers versus VMs. There's also the term container runtime, right? Where does the container runtime come in, and what is its function essentially?
Yeah, that's a good question. So container runtime essentially usually consists of multiple parts, right? So many people would say like, hey, what is the container runtime? Probably container D, right? But if you look really closely at what it is, it's container D itself is mostly more like a container manager, actually, where it like pulls images, it prepares them, right? Like it prepares the underlying file system for the actual container. But it actually does not run the container by itself, right? The actual container runtime, if you want so, is run C, because that's the actual piece of software that does the Linux namespace creation, that does the initialization, the actual mounts of the namespaces, right? That configures the C groups. And what container D is doing, it's calling essentially run C. And the container runtime essentially is responsible for then eventually starting the container and orchestrating kind of like the container, and then reporting to the kubelet. And the kubelet basically has an interface, right? So if you look at Kubernetes way, where kubelet has an interface, it's called CRI, right? The container runtime interface. And essentially containerd and all the other container kind of like runtimes or managers, or however you want to call them, have like so containerd has a plugin for this, but some others just have this natively. But essentially, they have some form of exposing or implementing the CRI interface, right? This is usually just through a socket, which you then tell kubelet to essentially use and manage the pods through this container runtime.
That's awesome. So I got multiple components actually running under the hood here with the kubelet, runc, containerd, right? And now we're adding vNode to the mix, and maybe let's talk a little bit about the alternatives. How does that look for a gvisor, for example? Does that similarly run on the node as well, or how would that interact with
Yes. So I mean, in the end, so how most container run. So there's different kind of like angles where you can integrate with, right? So there's container runtimes that basically completely replace containerd and runc. So like for example, Cryo is kind of like a complete replacement for containerd. So they directly implement essentially the container runtime interface the kubelet provides. What you can also do if you kind of like specialize on a certain container runtime, so for example, Kata Containers is doing this, you can do your own kind of like shim, right? So in between containerd and runc, there's actually another component. It's called the containerd shim, right? That essentially is a kind of like long-running process that is more or less kind of like the management interface for each pod, right? So each pod gets its own.
Actually, let me pull this up over here. That may make it easier to understand, right? So we have the node over here. We got the kubelet, containerd, that's what you were talking about. Containerd talking to runc. No, where's runc? Oh, no.
Yeah, it's this. Here. Like in our world, this is again a little bit different because we have this manager thing in between, right? But if you think about like just containerd, it's kubelet, containerd, the containerd shim, and then runc essentially. And if you look kind of at the process tree of a node, you will never see runc in a running pod, right? Because runc is kind of like the thing that starts it, but the thing that's not long running. What's long running is containerd, obviously, and the containerd shim. And the containerd shim runs per pod, and containerd runs once, right? So each pod has its own shim. And the reason for that is actually quite interesting because, so let's say you want to upgrade containerd, right? What you need to do is you need to replace containerd. But if containerd is kind of like the parent process for all of these pods, and you would replace it, basically all pods would get killed essentially, right? So
yeah, that wouldn't be fun.
So what containerd did is really they said like, all right, we have a separate process that essentially keeps these pods alive, and then you can exchange containerd, but not have to like restart all pods. So I think we have a question as well.
Yeah, it's regarding when you actually launch a pod, an Nginx pod in this example, and it arrives at the node, right? We have the scheduler that says like, hey, it should go to this node. I think the first thing that happens is obviously the kubelet now knows about this pod and needs to fire this up. But what happens from there? How does it actually look like?
Yeah, so the kubelet essentially has, and there's a flag for the kubelet, right, where you can essentially define the socket of like what to use. There, like in the past, there was like also a containerd flag, but since Kubernetes wants to make it as generic as possible, it's now just like a CRI socket that you specify, and essentially containerd listens on that socket, right? Like it implements this CRI interface, and actually starting a pod is usually at least a two-step process, right? So for a pod, there is something that's called the sandbox, right? That's essentially the network namespace. Sometimes it's also the PID namespace. So in Kubernetes, there's kind of like this spec.share processes, right? Where you can essentially share the same process namespace across different containers. But essentially what happens is the sandbox is created first, right? And the sandbox is networking usually. That means you hook up the CNI, which is essentially the component that creates the network interfaces, right, for the container. So this can be, for example, Calico, Flannel, Cilium. You can also just reuse the host network namespace, right? This is basically spec host network. And then essentially what containerd will do is, as a first thing for this pod sandbox, set up the network namespace, right? And it will wire essentially different things into this network namespace. And if you look at it, it's basically just a container as well in itself, right? So from the kind of like run C standpoint, there is not really much difference. Run C basically just get told. This is kind of like the so-called OCI bundle. So with the OCI bundle, it's kind of like a config format, right? Like defined from the Open Container Initiative. And that's essentially how you tell run C what to do, right? It's not kind of like nobody besides the kubelet gets past the pod YAML, right? Everyone else gets a different format, and that's the OCI bundle. And essentially then containerd creates that sandbox pod, or sandbox container, sorry, with like a separate network namespace usually, right? With the so-called pause image, which is just like a binary that basically does nothing. So that's also why you see always all these kind of like pause.
I'm going to take some notes here while you're explaining this. I think may make it a little bit easier for everybody to understand. I'm going to put the font size here to like super
so
high.
maybe I'm going too deep into each thing, but
no, like, this is great. I think we want to go deep on this stream, right? Like the whole goal is to be much more educational. I think there's so many talks out there that just scratch things on the surface, and I think there are lots of people in the Kubernetes ecosystem that do containers. You know, like they deal with containers every day for years now, for like I guess 10+ years. They started early in the Kubernetes space, and they may not be aware of what actually happens under the hood once, you know, the kubelet, they kind of know, I mean, there's containerd starting the container, but what does actually happen, right?
Yeah.
So I think if I understand you correctly, so we have the kubelet uses the OCI spec to communicate.
No, it's CRY. It's the
sorry.
It's the CRY interface. So, and that is basically yeah, exactly. It's just a socket, so it's just like a pipe, right? In the end, so like a socket where you can essentially make a connection to containerd, right? So it's not yeah. You could also, I think, even listen containerd like on a port and then use that.
Sure, and then we said containerd
creates
creating
exactly. So exactly. So it gets kind of that request from kubelet, right, to create now the sandbox. And creating a sandbox basically means it creates a container, like a very small, minimal style container. And even before that, so sorry, I mentioned that earlier, it basically creates the shim as a first thing, right? Because for each sandbox, it needs a shim, right? The shim is the parent process for each pod, if you want so. And it creates like a shim process. Exactly, and that shim process creates another socket. So that containerd can talk to this shim, right? So there needs to be some connection between containerd and its shim. That also works through a socket. And then the shim essentially gets the request from container D to essentially do start the pause container, right? And basically here it gets this OCI bundle. So also within container D, there's essentially a path where this is running, right? Yeah, shim receives command from container.
I'm trying to catch up.
It's more like config. It's not the actual command is maybe not. It's more like the config from container D.
Got it.
Yeah. And then essentially the essentially run C, right? So then the shim calls run C. And creates the container, right? Which is actually like a multi-step process, but in our case, it creates the pause container. And that pause container, the special thing about the pause container is, or the important thing about the pause container, like why do we even need this, right? It's the network namespace. So the pause container is all about the network namespace. That's what the pause, the sandbox is all about. Like we want to get the network namespace. Exactly. Yeah, launch. Yeah, so the shim creates the network namespace exactly, and then run C creates the pause container exactly. And then the shim also calls the CNI essentially to set up that network namespace.
Got it. Okay, so this is where the CNI comes in.
Yeah. Exactly. So, and then we have our so simplified our sandbox, right? And then afterwards, the actual container is created. So in our case, this would be maybe Nginx, right? And then the same process is done again. However, it's the same shim, right? So we don't recreate a new shim. We don't do a new network namespace. Instead, we reuse now this network namespace that was set up for us, right? To essentially exactly shim console security. Yeah, exactly. And then after that is created, the container is started, right? So basically, there's a difference between creating a container and starting a container. So this is like two separate API calls actually in the shim. But yeah, I mean, we can maybe just simplify this. Yeah, and then yeah, exactly. And then the actual container process is started within these now new namespaces, right? So yeah, so C is really calls run C again to create and start the Nginx container, right? And that means really creating now every other namespace that's required. So PID namespace, mount namespace for the container. So the pause container obviously has this as well for itself, but yeah, this is now separate from the pause container. So it shares kind of like the, I think IPC network is the primary ones with the pause container. And then the container starts running, right? And the shim reports back to container D. This is now running. And container D reports back to the kubelet. It's now running, right? With this PID on the host. Exactly. So how, okay, yeah, sorry.
Yeah, I mean, that's a good walkthrough. When we build vNode now, where did we see an opportunity to do more here in the container start process, right? Obviously, we're building on certain Linux kernel features here. One of them is user namespaces. A bunch of folks have been starting to get to know this one, given that obviously became part of Kubernetes as well. So if I were to run the native Kubernetes user namespaces, how does this process change here?
Yeah, so what we wanted to do really is, I think, two things, right? So there is first, we wanted to kind of like use, similar to kind of the pod sandbox, isolating more or less all the containers on a network level. We wanted to essentially create another sandbox. That's kind of like the idea of vNode, to essentially actually start the container in itself, right? So what we did really is we created something called vNode, which is an outer container similar to kind of like the pause container for a Linux user namespace. And Linux user namespace is essentially a cool way to isolate privileges and users from the host, right? So Linux namespaces are all about isolation. They want to isolate certain things. They behave all a little bit differently, right? Some are hierarchical, others not. And there is kind of like network namespace. However, there is by default, at least in Kubernetes, no way to isolate users or capabilities. So this means if you run a pod as root, right, it will be the actual same user as if you are kind of like on the host system without a container, right? And this poses certain problems. Like there are certain syscalls which are really dangerous. Like for example, take reboot, which reboots to just a machine.
Yeah, that would be fun.
If you can just run that, right, in a container, that's like pretty shitty because now the whole machine reboots and you essentially like killed all the other containers as well. So obviously there is needs kind of to prevent this. And yeah, the kernel usually does this through capabilities, right? There's capsysadmin, there's capnetadmin, and there's a lot of others, right, that kind of like essentially show or tell the thing what you can do and can't do. And there's also more like fine granular ways, but like capabilities is already a big one. And Linux user namespaces allow you to essentially hand out a different set of capabilities inside each kind of like user namespace. And these capabilities only allow you to do things inside this user namespace, right? So it's really, you cannot do any kind of like privileged actions anymore outside of your own user namespace. And that's a really cool thing because the most important things you can do in kind of like the root or initial user namespace, right? Where all kind of like the important stuff is. And by default, each container is started in that Linux user namespace. And this is really a problem because this basically is kind of like a huge security problem, which is also why like the general advice is to not run as root in containers, right? And that makes sense because if you, for whatever reason, have suddenly access to some unprivileged syscalls, you, in the worst case, cannot only break out, you can even sometimes brick the whole machine. And yeah, with vNode, it was really important for us to use Linux user namespaces because we saw that really as a way to improve isolation. And the second kind of thing is where we see like a lot of problems beside this same Linux user namespace and running everything as root is container start process, right? Because the runtime, there's like a lot of vulnerabilities in the runtimes actually, or in kind of like hooks within the runtime. So NVIDIA Escape, right, actually uses a hook. And there is in the OCI bundle, so the config, which we saw earlier, where you can tell how to start a container, it allows you to specify certain hooks during the process of starting a container, right, to manipulate certain things to your liking. So add devices or
attach a GPU, right?
Attach a GPU to like a container. And yeah, exactly. That allows you to also do, or there's a lot of room with these hooks for vulnerabilities, right? Because now you're operating at certain levels of the container creation process.
So just really quickly to reiterate here for folks, right? So once containerd initiates the container start process, what you're referring to is essentially we have the shim running here, and then we have run C running here. And this is essentially the startup process in order to launch this actual container or this set of containers here, right, which forms this pod. And what you're saying is there's a lot of hooks in these processes here that I, use, for example, the NVIDIA Container Toolkit to attach a GPU in, to this container that is being created. And obviously they run as root, right? Like they run as privileged processes on the system because they need to create these, network namespaces and things like that, right? So they have pretty high privileges here. And if something goes wrong, like with the NVIDIA escape vulnerability, we can look at it in a minute, then there is a potential breakout scenario before the container was even launched. And what we do differently is we pack all of this inside a hardened, secured container that we're launching effectively. So the entire, not just the workload that a user defines ends up inside, nested in our container, but also the entire start process. That's correct, right?
Yeah, so exactly. So yeah, we wanted to kind of like start a container in another container essentially, and because we think that we wanted to start it as a non-privileged user, right? So within a Linux user namespace, and to answer that question in the chat as well. So yeah, so capnetadmin is actually safe to allow in a user namespace as long as all the devices inside that network namespace are kind of like properly isolated, which they often are, depending. But this depends a little bit on your CNI. Yeah, so that essentially means that you can now start a container within another container, and that really helps because if there is kind of like a bad hook, which most of the breakout vulnerabilities actually that are out there are bad hooks, right? It's like something where something goes wrong, or like even in containerd itself or runc itself, there's certain like problems sometimes. Kind of the breakout happens before the container is even like created, which happens even before starting it, right?
Yeah, let's maybe dive deeper into NVIDIA Escape, given that that's actually the area. That's exactly what happened here, right? I did give a talk about this, and I pulled up some of the graphs and diagrams I had in this talk. This is from the AI Infra Summit in Santa Clara a couple of weeks ago. We can potentially go over these. So the NVIDIA Escape vulnerability was disclosed in July 2025 by Wiz. It's pretty high severity, 9.0, right? So it leads to container breakout, gives you root privileges, lets you run things as root on the container, pretty much like a C, command you can, or C script you can execute there. And that's obviously as bad as it gets, right? So in this diagram on the right-hand side, we see, a node, a Kubernetes node that has, GPUs in it. You have the NVIDIA Container Toolkit installed. And during the container creation process, there's this hook that gets called, right? In order to attach these, one of these GPUs or both of these GPUs here, right? And that's essentially where the problem comes in. We took a pretty close look at this vulnerability. Obviously, we're curious, does vNode protect against that, right? How is it different if you launch this with vNode? What happens is, and what was really interesting in this, I think Wiz actually called the blog post where they disclosed this, and it's like a 3-line Dockerfile change, right? That ultimately leads to an escape. So it's a pretty minimal way to break out here. We see a very minimal Dockerfile here. So you have these LD preload environment, this environment variable that you're setting inside here. You point it to, essentially an SO file, which is an extension file for loading shared libraries in C. So when the C code starts, it essentially reads this environment variable and says like, oh, this, I need to load this file here in order to load some shared libraries, right? So we don't need to always pack everything inside our C binary directly. And, last step is we're adding this file, right? Which obviously means we can now put some C code in this file, which will be, inside our container image. It could look like this here. This is a minimal example one of our team members, I think, created. Maybe it was actually from the Viz blog. I'm not exactly sure, but it's very minimal. It's very minimal here, where we essentially just open a file and say, okay, if this file is on the file system of the container outside of the actual file system, that is where the container is supposed to be somewhere, right? In this case, just on the root file system of the machine. Then that's obviously container breakout, and we could run any other C command here. Why is this such a problem? It's such a problem because this process that gets started when the container creation hook gets executed inherits the context from this Docker file, right? So generally, you would start this process, and this variable is obviously not something the user should set. And this file is not something the user should be providing in order to extend whatever container creation process the NVIDIA Container Toolkit here is supposed to run. But in this case, it inherits the context. So it reads this environment variable and then says like, oh, let me take a look at this file. And maybe, Fabian, you can explain, we're using here proc self, right? How does this actually work? So when the container gets started, we unpack the image of that container, right? So we unpack this file. How does this actually work, and how does it play in with this variable here?
So when you look at run C, right, like what happens is really, and this is kind of like called rootfs, right? So it basically makes a mount, right, to some location where it essentially uses different kind of like different kind of like container layers, right? And it mounts them all together in a single mount. And then you have basically some root path where your container should be pivoted in, right? And then essentially run C kind of like creates a new mount namespace, right? And in there, all kind of like the bind mounts happen. So you want to kind of like mount, for example, the Kubernetes service account token, secrets, whatever, right? And this is all done by run C. And also, obviously, the environment variables are set up. So this LD preload is set up, procfs is mounted, sysfs is mounted, right? And all this happens already while run C is kind of in this new container. And you can think of it kind of like as a partially created container, right? Where there is certain steps still missing before it's essentially actually usable. And one of the last things that actually happens is the pivot. So the pivot means I'm not seeing any kind of like root anymore or kind of like the actual host file system anymore. I only see kind of like what's in the container, right? That is like one of the last things that happens. And the hook they used, right, which is the create hook, happens before the pivot. So right before the pivot. So basically container is set up, environment variables are there, everything is there, except kind of the pivot. So you still have like access to the actual host system. And since you're running this as root, right, it's still kind of the same root as you would have kind of like in a Linux user namespace. So Linux user namespace in itself would have already worked because now you have kind of like this different root. But anyways, so what happens there and how this works is a proc self CWD points to the current working directory, right? Which is already the working directory of the container. And that is essentially kind of like slash within the container, right? And as we see in the line below, essentially that is also where the POC POC file is, right? Because if they would just do slash POC.so, that at that moment would be kind of like the host slash, right? So it wouldn't work because there is no
like on the node, right?
Exactly. So on the bare metal node, if you just do like LD preload slash something, obviously you could load something that's already there, right? But then you need to guess like what's actually on the host. We don't know, right? Could be like any node. So you want to
I
load.
mean, obviously, in an ideal scenario, you prevent that this context gets inherited in the first place, and that the user can set this environment variable, right?
Exactly. And I mean that the user should be able to set this, right? It's more that the problem is that the kind of like runtime respects this user set environment variable, which it shouldn't be, right?
Right. It should be respected inside the container after it's started, but not during the start.
It shouldn't have an effect, right, on the NVIDIA container toolkit. That's for sure. But anyway, so yeah, essentially, you need in the exploit a way to tell kind of like this hook now load something I control. And how do you do this? You do this by basically saying take the current working directory and take this file out the current working directory. And that is essentially how you do this with procfs, because procfs is already mounted and self is always the current process, right? And then current working directory is actually the working directory, which then will be pivoted to. So it's really kind of the next step that happens after the hook. And now the problem is LD preload is kind of like a special variable that tells you to load this dynamic library, right? And yeah, so what really happens is we are in this namespace now. The runtime sees this environment variable. It thinks, oh, I need to load this. It loads this out of the rootfs of the container, which is bad, obviously. And then you can create stuff on the underlying cluster, right? Because if you, and now this /owned essentially file is in the host path, right? So what's actually interesting is you don't have access at this moment to processes of this host because you are in this namespace already of the container, right? So you're like in all the kind of like Linux namespaces of the container, but you still have access to essentially the stuff of the host. And what they said, and that's totally true, you can, for example, now send stuff to the container D socket because the container D socket is just a file. And that is still available, right?
You could start a process as privileged container on that.
Yeah, and then you can basically start a process in a privileged container and easily break out. Like it's kind of like a multi-step process though to break out. Although that's easily doable then as soon as you can kind of like communicate or create files on the host. So yeah, that is pretty bad. And the solution to this, to kind of like fix this issue, is to basically either in the hook, which I think they did, right? In the hook, they set before they execute their stuff, this environment variable to like nothing, right? And that essentially prevents this.
Yeah, that was a great deep dive into this vulnerability. Obviously, pretty severe one. I think Wiz estimated that 40% of environments were affected that were running the container toolkit. NVIDIA obviously did a great job at immediately patching this and I think being very transparent here and addressing concerns. But container breakouts don't just happen in the NVIDIA container toolkit. They happen in lots of different environments for lots of different reasons. And part of this is really that this whole start process runs privileged, right? You got to be root in order to do these things, in order to mount the container images, the container file system, in order to pivot into it, in order to create the network namespace. Like all of these are privileged operations, attaching devices, right? So the whole process runs as root. When we look at vNode, it's a little bit different here, right? Because this hook here is entirely executed inside what we call a virtual node, and that virtual node is a container that we already pre-launched, right? Before we start launching any of the user-related, container. So if we have this container image with this malicious code, exactly same situation, and this hook here would happen, you still have a breakout of this container process, but you're still locked into this container, right? Which is kind of like a wrapper container around the container that the user has defined and around the entire start process of this container as well, right? So it doesn't just protect against vulnerabilities at runtime, also against vulnerabilities at creation time, which was obviously the cause of NVIDIA escape here. Anything to add to that, Fabian?
Yeah, no, that's right. I mean, so it's kind of funny, right? The runtime, the NVIDIA container toolkit, it's still vulnerable, right? Like we don't kind of like fix their vulnerability. We just prevent kind of the actual breakout to the host by allowing the user to break out to the vNode, right? And the vNode is just another container. So it's really not much different from the host. However, really this time you break out. You create basically that file on the vNode mount namespace, which then basically doesn't do anything because you're still kind of like part of this. And maybe what's also interesting, like a lot of other container runtimes that don't have kind of like this, I start a container somewhere else. So for example, like gvisor, or also Sysbox, they would be vulnerable because that hook is executed still during the actual creation process on the host directly, and all the kind of like security measures come after that, right? So they kind of like is more for the container process. It's not for the container creation. And that's often where these container runtimes fall short in the container creation process. And that kind of makes, vNode may be different, right? Because we already provide security in the creation process.
That's awesome. We have a couple of questions here. Hopefully this was interesting. I think it definitely sparked some thoughts and probably help understand what's under the hood here. There's a pretty simple question here. Do we have one virtual node per pod, or is it one virtual node for multiple pods? How does that work?
So the default is it's actually one virtual node per node per namespace. So obviously you cannot share a vNode across different physical nodes. That's not possible. But the idea is right now to have like a single vNode per namespace, right? Per Kubernetes namespace. It's also possible though to have it per pod, right? So it doesn't really matter. You can just, it's like a single line setting, right? That's super easy to do. But the per namespace aligns a little bit better with what we are doing with vCluster, right? Where kind of like things are synced into the same vCluster, into the same namespace. So that's the default, but yeah, both works. Both is possible.
And in general, we're seeing, with multi-tenant clusters, namespaces are often used as this kind of logical, grouping mechanism, right? Also for other, things like network policies, resource quotas, right? Like all of these are namespace objects. So, obviously the namespace is kind of like the logical grouping mechanism. So we thought, hey, let's make that the default. So if I launch 5 pods, I don't need 5, virtual nodes on that node, right? Because there's a teeny bit of overhead, right? It is an extra container launch, but it's super minimal. But yeah, why not? Why create 5 when you can have 1, right?
Yeah, I think the idea really is and then that's the cool thing together with vCluster, that there is certain, so vNode is not only about kind of like extra securities. Obviously, that's kind of like a big pillar of why we did vNode. It's also about giving possibilities, which actually a lot of other runtimes are not about, right? So if you look at gvisor, they actually take things away from you that you cannot do anymore, like kata containers. Certain things like are not possible suddenly anymore. For example, like host paths, or I don't know, like privileged containers and stuff like that. With vNode, we want to be a little bit different, where we want to kind of like give those possibilities still that you can run. Obviously, not everything works, but some things like, for example, Prometheus, where you have like the node extractor, or like I don't know, like Istio, or things that need to do certain things on the host, should still work, because we essentially allow these features, but we don't allow them on the actual host. We allow them on the vNode. And there it's obviously needed that kind of like the Prometheus pod mounts into the same vNode as this other pod, because
it's got
the Prometheus pod cannot really get the metrics now of this other pod without mounting kind of like to the same vNode, right? So it would only always get like its own metrics, which is kind of stupid, right? Why would you want to create Prometheus only capture Prometheus metrics? So that's kind of weird, right? So that's why it makes sense to have like a vNode per several pods, because the overhead itself it's really almost not there. It's like a megabyte of
it's just another process, right? Like
and it is a super minimal process. It's like a super minimal. It's like the pause process, right? That Kubernetes has. Nobody cares about the pause process being super big. Most people don't even know about it, right? So it's like a really small thing. But the idea is really to have it more, because that other services that actually expect a single node underneath, right?
So it feels more like an actual node, right? In terms of, if I launch a Prometheus in a node and I have like 15 other parts on that node, obviously that Prometheus has access to it. The way to put it in individual vNodes, that obviously wouldn't work. It would just see itself, right?
Exactly.
That makes a ton of sense. Yeah. You can obviously switch it over to create, a virtual node for each individual part, right? That would be the other model. I think that's pretty much the question here. Then we have another question around migrations, right? And let's split this question up into two parts, because someone's asking here about gvisor or Kata containers. Maybe let's start with gvisor. If somebody's running gvisor today and they use, the runtime class, etc., right, to leverage gvisor, what do they have to do in order to migrate to vNode and try that out?
Yeah, I mean, that's a good question. The question actually answers itself already. So yeah, it's just updating the runtime class actually. But you need to restart the pod for this, obviously, right? You cannot like do this while the pod is running. Like that's not working. But it's basically...
Is that a field you can change after creation of the pod, or do we actually need to delete and recreate the pod?
I think there's like very little you can. I think the only thing you can do is really image and labels, annotations. And I think there's one or two more, but it's like very, very limited what you can change on the running pod.
Yeah, so I change my deployment or stateful set or whatever it is, and then the replica controller would swap out the pods, recreate them, right?
Exactly. So you just update your deployment with this new runtime class, and then it works. And it's the same answer for gvisor or Kata container, actually. Like there is not really a difference, because we don't care about what the container before did, right? Because that will be recreated anyways by the container runtime. So it's literally just changing out the runtime class. And like all other things that were mounted, like for example, persistent volumes, MTD or whatever, will also be just again mounted into the vNode then. So there's not really anything you need to do besides installing obviously vNode first, right? So that's the first step. But then the second step is just exchanging the runtime class.
Yeah, we can probably start there. How do I install it?
Yeah, so it's just like a Helm command, right? So I think right now you need to essentially also define kind of like the platform connection. But in the end, it's just like a Helm command, and then there's this vNode runtime pod. You can also select kind of like by node selector, where do you actually want to use it, right? Because there's maybe nodes you don't want to kind of like have vNode running. And then vNode gets installed. vNode works very well with like all the different containerd versions, and it will essentially patch itself into the containerd config, and then it's available. We will create the runtime class object in Kubernetes as well, and then you just say like runtime class name vNode, and essentially you can start containers with the vNode runtime.
We had a question earlier, which we skipped over because we went really deep on the tech here. But there was a question earlier around, is there a free tier for vNode? So I think it makes sense to talk quickly about this. You were talking about the platform connection when spinning things up. So just to clear things up for folks, vNode requires a license key. And when you spin up vNode, just a Helm install, right, it would reach out to vCluster platform in order to get that license key. vCluster platform obviously has a free trial to get started with all features in there. If you want to test vNode, just contact us. We'll be happy to enable that for you so you can play around with it. We do have plans for a free tier, but we're not quite there yet. It's obviously quite some things we need to implement in order to automate all of this, make all of this work, so that you can just Helm install and you're immediately kicking off this free tier. But we're working on this part as well. But for now, if anybody wants to experiment with it, you'll find me on LinkedIn. You can go to slack.vcluster.com and reach out to our entire team and just ask for us to give you a license key and enable vNode for you if you wanna test this out. Yeah, here's the Slack channel if anybody wants to join there. And
you can try it out for free for sure. Like that definitely works. Don't have to need a platform or anything. Yeah.
Exactly. So let's dive a little bit into the differences here and maybe some of the kinks that we've seen in other tools here. So gvisor, Kata containers, those are obviously pretty established and known at this point. How is it different with vNode, right? There's some funky things that I think we've been talking about with like kubectl port forward, right? Like such a standard command. Can you elaborate a little bit on the limitations that people are seeing when they use something like gvisor or Kata containers? You said certain capabilities are removed, certain things are not possible. Can you give us just a couple of these examples?
Yeah, so I mean, so Kata containers works like fundamentally like a lot different than gvisor or like even vNode, right? So what Kata containers is doing, it's essentially launching like a mini VM, right? So there's different kind of like things you can choose from. There's like Firecracker. There's like, I don't know, like a lot of different options nowadays. Even I think they also have like their own one nowadays, which is I think like Dragon Ball or something like that. So there's like really a lot of different like ways how you can set up that VM. And then essentially Kata container starts this little VM. It essentially mounts these different rootfs things inside of it. And the problem, for example, why port forwarding is not working is because essentially the kubelet expects this network namespace that containerd creates to be the network namespace where it can find kind of like the things to connect to. And since that is not the case in Kata container, because now it's not about network namespace, it's kind of like about different OS even, right? This doesn't work really well without actually patching containerd or like kubelet. That's kind of like one limitation they have. Like also certain mounts are not supported. Like so, for example, certain subpaths are not supported. If you like Kubernetes, there's like different options, right, to do mounts, and there's like subpath how you can do like a subpath of certain mounts. That's not supported. So there's certain things that are definitely not possible, like host network and all that stuff as well, right? Like these more privileged things. And yeah, for gvisor, it's even more because gvisor kind of like the way it works, it intercepts everything, right? Not only kind of like certain syscalls like we do, it intercepts like almost all syscalls and then executes them kind of like in the Go runtime. And that's also a little bit a problem for things that are like on the hot path, right? So like open files, write files, all that stuff. If all those calls are like intercepted, it obviously adds a significant amount of overhead for these heavy IO operations, right? Or like operations that need to open sockets or whatever. And because of these kind of like intercepts things, gvisor is like very slow, and that's kind of like one of the main criticism about gvisor, that it actually, even though it's kind of like still container, right? It's not a VM. In many cases, it's actually slower than Kata containers because it's intercepting kind of like all these different syscalls and adding overhead. But it depends a little bit on your application. If you're not using that many syscalls, then it's obviously like a lot faster. So it kind of like depends on your application, what you're doing there. Are you reading a lot of files? Are you doing like a lot of network requests? Like what are you doing? And then based on that, it either improves your performance, right, compared to Kata containers, or it makes them worse. But yeah, I think that is one thing. And the other thing is they don't implement certain syscalls at all. So obviously certain applications wouldn't work at all in gvisor, right? And they kind of see it more as a runtime to kind of like prevent certain things rather than enable certain things that weren't able to do. So you never could run things like Docker and Docker with gvisor or stuff like that. that just doesn't work because there's certain kind of privileged syscalls that Docker needs that are just not implemented by their kind of like user land kernel in gvisor.
Yeah, so I think for us, it's a little bit like vCluster, right? We're trying to give more autonomy to you, and you feel like you have your own cluster now, right? But then you actually have less permissions in the underlying namespace, right? Like by default, we just sync pods and services, right? So the vCluster pod can, the syncer can run with like super minimal privileges. It doesn't need to create deployments and stateful sets, and most of the CRDs are going to stay within the vCluster. So it actually has a lot less permissions. Like the tenant gets a lot less permissions in the underlying, traditional cluster, the host cluster that this vCluster runs on top of. But inside of it, I can actually do more things now, which is kind of ironic, right? We are applying that same principle here to vNode, right? And trying to do the same thing we did for vCluster, give the tenant more autonomy, but not actually give them more autonomy on the underlying actual physical host or virtual machine that makes up this node.
Yeah, so I think kind of like that's an interesting idea to kind of like, instead of preventing things, make it instead secure on the underlying layer, right? So people can do Docker, Docker and Docker even. They can run their applications as root. They can add extra capabilities that they need for things like Istio, for example, that requires like capnet admin. But at the same time, it's secure because of this combination of security features. And a big one really is these Linux user namespaces that isolate these capabilities with a couple of tricks on the seccomp layer and procfs, sysfs layer. So yeah, that really allows us to allow certain applications, even though they would be deemed insecure in a regular Kubernetes cluster.
Like privileged containers, right? I can literally run a completely privileged container, run it as root, and inside, as long as it's inside the vNode runtime or it gets fired up by the vNode runtime, it's actually going to stay secure, and you can allow that to your tenants, which is unheard of in multi-tenant environments, right? Like if I take a regular EKS cluster and I allow privileged containers there without vNode, that's going to be, that's anarchy pretty much, right?
Yeah. I mean, obviously there are limitations, right? You cannot like install drivers or like, I don't know,
right.
Do like really rebooting or stuff like that. We obviously prevent this. So
reboot would be something that would affect everybody.
Reboot cron job is obviously not going to work in vNode.
Yeah. But I guess we could kill the vNode to fake it.
But like still, there is definitely limitations to it. But there is really, especially like you can even start like a second Kubernetes cluster, like with K3s or Kind, right, inside a vNode, and that completely like unprivileged, which is really cool. And you don't need to modify K3s or Kind or anything, right? Like it runs just plain from GitHub out of the box, which is really awesome and allows you to do really cool things with vNode, where you can run your CI jobs, for example, now, which usually require like Docker and things like that, right? Securely in vNode, you can allow certain like more root level applications, right? So it opens up quite a lot of interesting use cases without having these annoying limitations where you cannot do port forwarding or it slows down your application or stuff like that.
I want to quickly double click on user namespaces, right? You've been mentioning user namespaces quite a bunch. We've been talking about this. We'll see it in action in a little bit as well, but let's first talk about the Kubernetes feature, right? Because they introduced user namespaces in Kubernetes. How is that different from how we use user namespaces in vNode? And what makes it more secure in vNode than the regular feature you have in Kubernetes?
Yeah, so the new feature in Kubernetes really is, so it's like spec.host user false, basically. That's how you enable it. It's maybe like a little bit weird that you have to set it to false to enable it.
Love those flags that are default true and
like, that's essentially how you use it. And I mean, in the end, it's also like more or less the same idea. However, a little bit differently, because what they do is they put every pod, right, into their own user namespace. They kind of like do it on the sandbox level. which is great already. Like you should do this if you don't use vNode to enhance security. It definitely helps a lot. However, they still don't start it kind of like in another container, right? There's no other sandbox around it. And that's kind of like the main difference besides all these SecCom filtering and procfs, sysfs, what we do. And what they do is still kind of like, so you can also allow now privileges in a more kind of like secure manner with this. However, like a lot of things will not work still. So like Docker and Docker will not work, or like K3s doesn't work. And it enhances your security a little bit. And it does also help running, especially kind of like rootful containers as non-root automatically. So it's a really great use case for this actually. However, yeah, it helps kind of like on this capability and user mapping layer. However, it doesn't kind of like prevent this container breakout that we mentioned before, because like the container is still started on the host. So this hook would still run the same.
So the NVIDIA container toolkit, right? Like that process we just saw,
Exactly.
it would still inherit the context from the Docker file, because it's really the container itself in the end is going to run in the user namespace, but not the creation process of that container.
Yeah, so that's still kind of like a problem, and but it already helps with some things, right? So that's definitely a great addition that they did, and it's kind of related to what we do, but we do like a little bit more and a little bit more in a different direction, where we really say like, hey, the container is started in another container to add security, and then also we have kind of like these different additions that filter things more on the SecComp layer, so more like what gvisor is doing, and with certain emulations and procfs, sysfs to allow Docker and K3s and all that stuff. So that's really important for making that possible.
Yeah, so to repeat what you just said, we launch a wrapper container instead of the user-defined container inside a namespace. I think that's number one, right? The second thing is we do SecComp filters, just like gvisor, but we don't do quite as many, right? Like we do that much more selectively, so we don't impact performance as much as
gvisor. We only do them on like a couple of syscalls, which are like all non-hot path, right? Except if you like write an application that mounts a million things a second, then maybe you see like a little bit problems, but nobody does that, right? So that's really something that's not happening. And we run them like very selectively on kind of like more these privileged syscalls. You wouldn't run a lot. You just run them maybe initially to set up some stuff. But there we kind of like run them. And yes, we have kind of this outer container, this kind of like pause container too, if you would want. So that essentially runs outside to kind of like give a secure environment how to start a container and create a container, right?
Yeah, and then there's a third thing you mentioned, and that is emulation of procfs and sysfs. And that becomes very important when you want to run workloads inside this container to make them feel like they're actually running on the node, right? Because it's not good enough to allow them to be root as a process. We also need to allow that when they run, show me all the processes, right? And that's essentially what we do with procfs, right? If I understand you correctly.
Yeah. So I mean, in general, so seeing all processes, that's something that's not really privileged. That's something you can always do, right? Like even in a regular container. However, there's certain things in procfs and sysfs that is kind of like privileged. So for example, like changing kernel parameters, right? So like sysctl in setting like certain like IP forward or certain kernel parameters. It's definitely something you cannot do in a regular container without extra capabilities, right? So that's kind of why we use this procfs and sysfs simulation to kind of like pretend this works, and then also allow certain things which we deem are secure, right? Instead of kind of like just denying it by default, everything, which is essentially what the regular kernel does, right? And And then also kind of like we emulate certain functionality on a more like secure level. So for example, like getting the uptime of the machine and all that stuff without essentially doing it on the kernel level, and rather doing it in our like runtime level, right? And this is mainly all done to enable things like Docker and these other
pretty advanced kind of workloads to run them there as well. Yeah, that makes sense. So just to recap, the things that we do differently than other tools, right? So user namespaces, but instead of launching the user's container in a user namespace, we launch our wrapper container, right? The pause2 kind of wrapper container inside the user namespace.
Exactly.
We do selective seccomp filtering instead of filtering all the syscalls, which is much better for performance. Network heavy things, for example, data intense things where you need a lot of file reading. I assume all of this is pretty critical for AI type workloads on GPUs. I assume there's so much network traffic happening there. And then you have procfs and sysfs emulation to really allow even super advanced workloads, because we want the virtual node to feel like a real node, right? Just kind of like we want the virtual cluster to feel like a real cluster, right?
Yeah.
That's always the goal here. Cool. I think we covered a lot of ground here. Let's jump in and see some stuff with the keyboard, right? Do you wanna share your screen and show us potentially how an exploit could look like, and then we can take a look how it would be different with vNode, a little bit more hands-on.
Yeah, so let me share real quick my screen. 1 second.
And in the meantime, while Fabian's pulling up his screen, if anybody has any questions, feel free to drop them in the chat while we're working through, more of this like hands-on demo as well to take a look at vNode. So feel free to just drop it in, LinkedIn, YouTube, wherever you guys are watching.
Perfect. Do you see my terminal? Did that work?
Yeah, it should be up now.
Perfect. So I have a couple of like different use cases prepared. Although I want to show first like how to actually break out in a container, right? So I have a small Kubernetes cluster set up, which is a kind cluster. And the only kind of like change I did to this Kubernetes cluster is I already pre-installed vNode, right? So when we see like runtime classes, we see there's vNode and vNode launcher. That's more like an internal thing. But essentially to kind of like start a pod with vNode, you could say privileged, and then here you would just add like runtime class name vNode, and then you could even run kind of like certain privileged operations here in a secure way, where, for example, said like security context privileged true, right? Or like host PID, which is even worse. And that would be then ran within a vNode. So to do this, I actually start now such a privileged workload. So this is gonna get started, and this is now without the vNode runtime, right? And now I can exec into this, and now this is obviously just a command to get like a bash into this container, right? And this container, before we let me show real quick what that is doing. So this is basically more or less the same thing as above, right? Here, with the difference that this is not running vNode. So I have like the host PID namespace, so that is not isolated, and the security context is privileged, and it's basically doing nothing. Does that make sense, Lucas?
Yeah, it makes a ton of sense. We got a privileged container. We are enabling host PID, and you opened you kubectl exec into it right now. So I assume breaking out is pretty easy, right? Because we got a privileged container with full access. So yeah, I wouldn't be surprised if you're on the host pretty quickly.
Yeah, exactly. So the kind of like, that's also the name of the container, right? I call this nsenter, and that's kind of like the magical command here as well, which basically tells now the the kernel that I want to be part of all the Linux namespaces of the first process ID, right? And the first process ID is actually the kind cluster process ID because I share the PID namespace with it. And then I just tell I want to run bash inside that kind host, right? And if I do this, I'm directly root on the kind cluster. And this is kind of like the worst thing that can happen because now I really see all the host processes, right? Everything runs as root. It's really bad. I'm in this here, right? Like I'm this process tree actually. But yeah, I see basically, okay, this is not.
Yeah, maybe for everybody's context, what you were just highlighting there. Oh, can you scroll up again? We see the container D and container D shim here as well, right? So everything we talked about at the beginning of this session can actually be seen here in this process tree. You see the container D, the shim, the pause container, right?
So exactly. So container D is kind of like the daemon, right? So that is like running as a single process. That is this one. We have like the kubelet here running as well as a single process. And then like for each container that we have, or like each pod, there is like one of these running, right? So each pod is this. So this is a pod, this is a pod, this is a pod, right? And then you always have this pause thing, which is the sandbox, which is like super minimal. You see that here, like that almost occupies nothing. And then you have the actual process. So this is, for example, the etcd container, right? That runs here the kind control plane. Here's like kubeproxy. Here you have like their CNI, right? There's like actually vNode manager here. So this is like all different containers and pods essentially. And what's also interesting, I can talk to the
for everybody's context. So there's a vNode manager installed, but we didn't use it. We didn't set the runtime class, right? So this container was started just normal directly with container D.
Exactly. And now I can also see essentially. So I broke out here, so I really have like full access to the host. So now I can talk to the cry interface directly. So with this, I'm talking not to the kubelet, I'm talking to actually similar how the kubelet would talk to container D through the container runtime interface, right? And this is a nice thing to actually see what's going on. If, for example, your Kubernetes cluster is down or the kubelet doesn't work anymore, you can see like what's going on at the container side, right? And yeah, here you can basically see all the pods, right? So this is a little bit, can I make that smaller for a second? This shows basically all the different containers, right? It shows you the name, and then it shows you also the pod which this container belongs to, right? And the namespace as well. So this is like really kind of like Kubernetes aware already. What I can also do is I can talk to kind of like the without a cry. I can, and this is this thing essentially, where I can
you make it a little larger again?
Oh yeah, sorry. This.
Yeah, that's better.
Yeah. So I can basically do task. Oh, this is just like a. Sorry, this is I/O. And here, this is more like on the underlying level. So this obviously has like a lot less information, right? Because this is just showing me the task, which is how container D under the hood calls these different containers. And it only shows me kind of like the task ID and the PID ID. And the interesting thing is it now doesn't distinguish anymore between sandbox, which is in the Kubernetes world kind of like pod, right? And container. It just shows everything. And you will see here, this kind of like matches certain like sandbox and this. So when I look up at the PIDs, right? So here I see the PID. I would see like 1,459, and this is like oh, this is in the other. Oh no, this should be 59. This is this, right? So this is a sandbox actually. But I don't see this here anymore because like on the lower level, container D doesn't really distinguish anymore. It's like all tasks, right? And for the vNode, then eventually it will be the same. Like vNode itself is also just a task. So this is like really also interesting that you can talk to container D on different levels, right? You can do kubectl get pod to see it from the Kubernetes perspective. You can do cryctl to see it like from the cry perspective, and then you can do CTR, which is really on the lowest kind of like containerd perspective.
Where you don't want any of your users to end up having control like we do here, right?
That's exactly. And this is kind of
weird containers. It's the first thing you put into your Opa or Cavano, right? Like, don't allow any privileged containers, right? That's one of the first policies any sysadmin puts in place.
Yeah, you don't want to see this here, right? Like, this is really bad. This command is like really something you wouldn't want to allow in a regular Kubernetes cluster. And now I can also go back into my container, right? So now I'm in my container again, and I can go back even to my host machine now, and I'm back to my host machine.
Cool. All right. Let's see the difference with vNode, right? You got vNode up and running already, I saw. So let's fire up the container and see if you can do the same thing, right?
Yeah, let me delete this pod real quick. So that is deleted. And I now prepared the same thing with runtime class named vNode, right? And what I can do is I can apply the same thing, and it's now running already, right? So I can do again, I can exec into it. And do like bash, which is the exact same thing I did before, right? So when you go up, it's this. And now I can run the same command, this dangerous, which we saw here, right? I can even copy it. And I see, I'm again in this, but now when I show the processes, it looks a little bit different, right? So what I see actually now is something like this. And this looks like a lot different from what I did before, right? Where I said,
yeah, where did all the other stuff go, right?
Exactly. Like, where did everything else?
Where's the CNI? Where's
Kubelet? Where's CNI? Where's Kube API server? Where's all that stuff, right? And that is actually kind of like the beauty of these container and container things, because now I'm in this underlying vNode container, and I only see other things that run inside this vNode container. I see, for example, like my own pause process, right? So I see actually my own sandbox, and I see kind of like my own container shim, which is interesting.
You still feel like you're actually on the node there, right? But I guess the only hint is you don't see kubelet and containerd, right?
Exactly. So I can like get my own pod like container, right? It seems like certain kubelet stuff is still there, but it's only there for my own pod, right? So I can say like, there is my logs, there is my kind of like volumes, right? Everything is there that I kind of need for things like Prometheus, for example, to read like this. But what's not there is everything I shouldn't see, right? So like these other containers, these other processes. But if I start like a second container in here, I wouldn't see, or I would see actually, if it starts in the same vNode, this process as well, right? So similar to how I see this pause container, which is actually a different container even, right? Mm-hmm. And I also see the shim because the process and the container and the pod was started within this vNode, right? And then there's kind of like this thing here, which is just the init. It's kind of like a pause for vNode, right? Doesn't do much. And yeah, on the underlying node, actual underlying node, to maybe show the contrast there, right? So I now log into the kind pod, similar to what I did before. So this is now actually the underlying node, right? I see this, which I kind of like entered. So we see vNode init here as well, right? Like we see the actual shim, and that was the shim we saw before. I see this is all just run as non-root, right? So this is just like some random user ID, but it's not root. And that's kind of like the beauty of these Linux user namespaces, that you can run things now seemingly as root, but not actually as root.
So we have a shim and a shim, right? We have a shim and then vNode inside, and then that vNode process is already in a user namespace, and then we have the actual shim, which would be the container start process with the pause container for the actual user workload, right?
Yeah, and here could be multiple, right? So there is like, so this is basically a single vNode, these two processes, and this is a single container, similar to how this, and this is not a, this is a single pod, sorry, similar to how this a single pod is, right? So this is a pod, this is a pod, and here you basically see the pod, and this is the vNode on top, essentially.
Yeah, so if you're creating a second container in the same namespace in your client cluster, and it would end up in the same vNode, then we're going to see that here as another shim, effectively.
Yeah, I mean, let's do that maybe real quick. So I have, so let me check. I have, for example, like host network that I can use. So I can do, yeah, this also to show that this is in the same networks. And now I can basically do Docker exec again, right? And I see it started here, right? So yeah, unfortunately, this is like the same init process, right? So that's kind of, but it's now 2 times, right? So it's 1,
yeah,
2.
One is the host network container, the other one is the NSEnter container.
It's the same vNode, and that's pretty cool because, yeah, when I log into my NSEnter,
can we go back to the NSEnter? Yeah, and we should see the second one as well, right? If we're kind of breaking out.
Exactly. Oh yeah, I need to break out. And now here I see basically the start process, right? This is myself, so this ran NSEnter, and this is this other process in the same vNode, right? So it's the same thing.
Your host network part in the same default namespace.
Exactly. So this is pretty cool because now things like Prometheus work and can essentially scrape the metrics of this one, even though I am part of another pod, right? Yeah. So this is pretty much the overview of how this works in reality. But obviously, you can also configure that like each pod should get its own vNode, right? Like this right now is just the default, that it's in different or per namespace basis.
Awesome. Yeah, I think that's pretty cool. I guess one thing we could do over here is we could potentially even put a fake kubelet and a fake containerd process in there as a honeypot, right?
Exactly. Yeah. So there is already kind of like a fake containerd socket, right? So if people want to connect,
right. You just don't see the process in the process.
You don't see the process because that's actually the node runtime who's kind of like doing that. So yeah, that would be also possible actually.
Yeah, it's interesting. Kind of really emulating it. Yeah, could really be like a honeypot depending on what you do.
Yeah, you can do like kubelet and kind of like pretending systemd or stuff like that, where you can then install services on your own.
Yeah,
that will work.
Yeah, that's pretty interesting. We're coming up on time here. We've been on the stream for almost an hour and a half. We went pretty deep on all the tech. Hopefully, folks have been enjoying this. Maybe as a last topic, what does the future hold? I know you're working on some really exciting things. We saw vNode as a container runtime today, which is how we envisioned it. It's obviously really great. You install it once. These vNodes get created automatically. But one of the questions we've gotten a couple of times, obviously, people, in some environments where they're on bare metal, sometimes virtualization is not even supported, right? That's the case on a lot of GPUs where you don't want virtualization and the overhead of it, or it's just not even supported by the hardware. So people have asked us, can't this be more similar like a VM where I can carve out a node and I see it as a node in my Kubernetes cluster? Because couldn't I say, okay, I want 2 GPUs out of the 8 I have on this server, and then I want 5 here, and now I have 2 separate nodes, right? Maybe even 2 separate nodes in 2 different Kubernetes clusters, right? Because the way it works here is you have the underlying node with your 8 GPUs as a node in your Kubernetes cluster, and vNode effectively creates these virtual nodes. But these virtual nodes, they don't show up as a node, right? If I run kubectl get nodes, I don't see my virtual nodes.
Yeah.
But you're working on the other approach as well. Do you want to give us a little bit of context on what the challenges are in order to make that work?
Yeah, so definitely we want to like also allow vNode, and many people confuse it for that right now already, as actual nodes without kind of like this, just using it as a container runtime. So if you make the analogy, right, like Kata containers is really the container runtime, and Kubelet would be kind of the same thing for VMs, where you can basically spin up VMs to have as your Kubernetes nodes, right? And vNode can be also a way to spin up VMs for vNode, for your Kubernetes cluster, to actually see them as actual nodes, install things there, and then do this on a more Kubernetes level. And yes, there's still like a couple of challenges. So we are working on like making eBPF possible to even run things like Cilium in there. So we already have worked on things like GPU pass-through, right? So you can install GPU operator inside the vNode already if you join it into a Kubernetes cluster. That already works. But there's still some limitation, like eBPF, for example, which we are working on, and certain network-related things.
Yeah, so the analogy might be, like gvisor, Kata containers, those are runtimes. And right now, vNode is like that, right? It's a drop-in replacement pretty much for gvisor, Kata containers. Ideal for scenarios where you can't run VMs or you don't want to run VMs, but you want stronger isolation than gvisor has and better performance because you don't want to filter all of these syscalls, right? But you don't quite want to take the step to Kata containers, which creates VMs, right? That's where we are today. On the other side, we have KubeVirt, which is gaining a lot of attention, obviously, which creates VMs more on demand, and then I can kubeADM join them into a cluster as node, right? That's quite different than the container runtimes we've just talked about, like Kata containers, gvisor, and vNode. And we're envisioning that vNode can also be more like a KubeVirt, where I can say, hey, spin me up 2 virtual nodes and join them into this cluster. And now I can, the scheduler can just schedule workloads directly in there. Do we envision then also obviously running the kubelet directly inside the vNode, right? That would be the consequence of that, right?
Exactly, yeah. There would be a kubelet inside the vNode. There would be like an actual container D inside the vNode.
Also the CNI, right? You would run that separately
like
for each
CNI,
vNode.
yes, so it's really then a separate Kubernetes node at this point, and acts sort of as a VM if you would want so.
Yeah, that's awesome. Do we ever think about putting a kernel in as well and then actually making it a VM? What do you think?
Not sure. Then we are like in actual VM. Right? So then we would operate on a different layer. We would use probably something else, right? Similar to like Kata containers or Kubelet would be doing. So yeah, we'll see, I guess. But
never say never, right?
Yeah,
Awesome. I think this was an awesome stream. I saw a bunch of people join in here, so many different comments and questions here. This was awesome. Thanks everybody for actively participating here. You'll find us on the Slack channel. Again, that's slackvcluster.com. And you can obviously also check out vNode. Just head to vnode.com to check it out. Again, if you have trouble setting things up, you need help with the license key to get vNode activated, just reach out to us. You'll find both of us, obviously, on LinkedIn, on the Slack channels. Don't be shy and just reach out. And yeah, with this, we wrap up the first episode of our Across the Tenancy Spectrum live stream session here. Very, very excited to see what's next. If you have any ideas of technologies, we don't want to just cover technologies that we're building directly, but also technologies in the space overall that we're seeing our user community actively use in combination with vCluster, vNode, right? There's a bunch of different things. I think we're baking certain things in. For example, Carpenter recently, we added that to vCluster with auto nodes. So we're probably going to do a deep dive on Carpenter at some point because that helps, in terms of cost optimization, right? Tenancy also means how can I run efficiently with my multi-tenant cluster. And in this series across the tenancy spectrum, really we want to dive into a new technology every time and go as deep as we can, This one was obviously pretty deep on the Linux kernel level here. Obviously, not every technology will go quite as deep as today. If you have any questions and if you have any suggestions for technologies we should cover in the future, just reach out to us. Thanks for tuning in.
Thank you.
Bye.